Hey again, everybody. Hopefully you've gotten the hang of some of the basics, because to get to the next step, you really need to have a good understanding of how to see those radii every time you go to do one. So make sure you practice those basic ones before you maybe try one like this. So anyway, let's just get right to it. Y equals x squared. Y equals 2. Same region, but this time we're going to revolve it around the x-axis. So back to the x-axis, but the problem with this is the region is different, so it's going to look a little funky. So I'm going to do my same strategy. I'm going to reflect, shade it in, and try to get a look at this thing. If I revolve the line y equals 2, well, that's just a cylinder, right? That would be all the way around, okay? But when I go to, and actually that would show up here too, really. Okay, I have a cylinder. If I revolve y equals 2 all the way around, I'd have a cylinder. Although I just realized I made my my perspective both go in, but hopefully you still see. This would just be a cylinder. The inside part, there's my Hershey Kiss again. So it's basically like I have some kind of cylinder can where maybe it's filled with water, and then I squish in a Hershey Kiss, all the water comes out, the extra water, and the volume I want is how much water is left over after I squeeze this Hershey Kiss in. Okay? So I know it sounds ridiculous, but that's really what it kind of looks like. Okay? So the problem here is there's two different volumes that we're dealing with. We're dealing with the volume of the entire cylinder, and then the volume of the Hershey Kiss that's actually coming out. There's no way to really get the volume of the orange region as it is, as in one step or in one shot. So I sort of have two radii here. I have like a big R and I have a little r. Okay, you could use R1, R2. It doesn't really matter, but I like to use big R, little r, because big R is literally the bigger radius and little r is obviously the littler radius. So when I go to do my volume, the good news is it's still this, right? It's still pi r squared, but it's going to be pi big R squared minus pi little r squared. Kind of like when we did area between curves. Okay, it's essentially the same idea. You could find the area of this rectangle, subtract the area under the curve, and what's left over is orange. Well, instead, I'm going to find the volume of the entire cylinder and then take away the volume of the Hershey Kiss. And what's left over is the volume I want. Now, since they're both the same limits and everything, they both have pi, I can really just set it up like this. And I think, honestly, the biggest mistake sometimes people make is they'll do big R minus little r and then square the quantity. And that means something different. So you have to really look at what the radius is, how many pieces are there, and set it up accordingly. So if I do this right, big R is just 2 minus little r, which is x squared, and then dx. Oop, that was 0 to, what did I do? 0 to square root of 2, I guess, here. 0 square root of 2. So it's 4 minus x squared, squared, right? So x to the 4th. So dx. And from here you can just kind of use the calculator. Although this one's not so bad because it's x to the 4th. Although I guess square root of 2 doesn't make it nice. But either way, it doesn't matter. The concept is the same. Find the big radius, the little radius, and it's almost like two separate problems. Okay, but you can combine them into one step here, but it's really two separate volumes. Volume of the cylinder minus volume of the Hershey Kiss, and that should take care of problems that look like that. Okay, as always, let me know if you have any questions, and I will talk to you later. Bye.